Good day, everyone. Allow me to share with you my research entitled Establishing an Environment-Friendly Chromium Plating Process Using New Generation Ionic Liquids. I'm Eden May de la Peña, the project lead for this research. Our project is particularly concerned with improving a popular surface treatment technique called chrome plating. Chrome plating is the process of electrodepositing a layer of chromium on a metal substrate. Chrome plating finds its use in different industries including the automotive, architectural and construction, household hardware, and marine industries. One problem with the traditional method of chrome plating is its use of hexavalent chromium in its plating bath. Hexavalent chromium has severe environmental impact. It is extremely toxic and carcinogenic. Consequently, the process is heavily regulated and stringent measures that are applied to manage toxicity issues increase the capital and operating costs of this process. This suggests a need to look for an environment-friendly plating process that may be offered to the local industry as a good alternative to the hexavalent chrome process. The recent emergence of ionic liquid electroplating offers the possibility of overcoming these challenges in chrome plating. Unlike the traditional water-based plating process, ionic liquid plating uses diputectic salts that are non-volatile and, more importantly, non-toxic. Past research have proven the feasibility of plating some technologically important metals such as aluminum, chromium, and titanium using ionic liquids. In the Philippines, there is currently no effort towards understanding and exploiting ionic liquid technology specifically for surface treatment of metal substrates. This project attempted to conduct chromium electrodeposition on metallic substrates using the new generation of ionic liquids. It hoped to create a DES-based chromium plating bath, optimize the plating process to create a dense chromium plating deposit. It hoped to obtain an optimum plating recipe that will yield chromium deposits of consistently high quality, and this project is also an attempt to catalyze research in ionic liquid electrodeposition by establishing technical capabilities in chromium electroplating. In the 3 years of this project, we were successful in providing the promised deliverables. The research was able to produce good quality chrome plating on different substrates using an optimized ionic liquid plating bath. We produce high-quality publications and help both undergraduates and graduate students in their thesis projects. The team was also able to visit the Surface Engineering Division of MIRDC and a laboratory at the Materials Center at the University of Leicester, one of the pioneers of ionic liquid plating in the UK. If the industry adopts the proposed technology of our research, some of the potential benefits include lowering the cost for maintaining chromium plating operation. This is useful for existing chromium plating companies where a large portion of the operating cost goes to treating wastewater effluents laden with toxic chemicals. Another benefit is that it could lower the hurdles for future investors to engage in chromium plating business. To start a chrome plating business, a huge amount of capital investment is spent on getting environmental permits and showing evidence of stringent effluent treatment procedures installed in the plant. Such will be reduced with a clean chromium plating process. Lastly, probably the most important impact of the project is that it will reduce the environmental dangers associated with chrome plating, thereby creating a cleaner and greener future for the country. Looking back, I think the question that I want to ask myself is doing a project with DOST worth it? Let me be honest, undertaking any project is stressful as it is, more so if it involves funding. But for me, yes, the journey was totally worth it. In those 3 years, I had my share of stress and some low points, but it also came with the thrill of adventure and moments of triumph. Ultimately, there was fulfillment. This experience of closing my first project has given me the boldness and confidence to venture to more research unknowns in the future. Hence, I sincerely thank PCIEERD and the DOST for supporting me in this great adventure. They took a chance on a stranger, and I'm better because of it. The progress of society has depended largely on man's ability to understand the world through the lens of scientific research. The Hungarian Nobel Prize winner Albert Szent-Györgyi once described research as seeing what everybody else has seen and thinking what nobody else has thought. Our country's goal of progress and self-sufficiency will only be realized with the help of people like you. We need you now. The country's future depends on you. As the poet Antoine de Saint-Exupéry once eloquently said, as for the future, your task is not to foresee it, but to enable it. With that, I would like to express my immense gratitude to our funder, DOST, thanks to PCIEERD, to UP Diliman, to the Triple M Department, SETLab, our industry and government partners, and of course, all the researchers who became part of this project. And last but not the least, thank you all for your attention. Have a great and safe day, everyone.